Alright, so I'm setting up an acylation of Meldrum's acid reaction for the first intermediate in our synthesis. I'm doing this on the microscale and 500 milligram scale, just as a pilot reaction to see if the acylation works. We have some recrystallized Meldrum's acid that we recrystallized from acetone over the previous couple of days. We're going to be using pyridine as a catalyst and heptanoyl chloride as our acyl halide. The reaction is going to be carried out in DCM on ice. Alright, so we have half a gram of our recrystallized Meldrum's acid, 2 mils of dry DCM in there. So the first step will be to add this. So the Meldrum's acid is dissolved now. We're going to be adding a catalytic amount of pyridine. So we're going to be adding about 700 microliters total, 4 times the molar equivalent of the Meldrum's acid that's in there. And we want to do it over a period of about 10 minutes, but since I don't have any kind of addition funnel that is accurate with small volumes, I'm just going to separate it out into 200 microliter additions spaced a few minutes apart. The reaction solution still remains clear. Okay, so the pyridine has been added, and now we're going to add some of the acyl chloride, which is diluted in DCM, to the reaction mixture. This should theoretically turn it orange. I'd like to be doing this under nitrogen, but don't have a Schlenk line set up right now, nor do I even have a balloon. So we'll make do with what we have. See, almost it looks like a solid precipitated out. We'll see. Alright, after the second addition of 200 microliters, definitely starting to get some solids, which you can maybe see in there. Alright, after the third addition of 200 microliters, it's starting to look more like urine color, definitely dark orange versus dark yellow. We've added about half of the acyl chloride and the DCM, and it looks like there's definitely a lot more solids in the reaction now. I don't think the stir bar is really moving the solution around too much, so over the next 20 minutes we'll add the remainder of the acyl chloride and then look about acidifying it and purifying it, or extracting it out with DCM. So upon the addition of the fourth equivalent of 200 microliters of heptanoyl chloride, perhaps it was added a little too fast. We have these two different layers coming up. I don't know if it's because there's water in the solution or what. Alright, so after addition of all the heptanoyl chloride, the solution is now a dark purple. There's actually kind of some solid chunks in there. It's going to stir for a little while longer on ice, and we're going to let it stir at room temperature. Alright, so the reaction's been stirring for another 30 minutes at room temperature. It still definitely looks dark reddish purplish. Did a TLC plate, spotted 4 positions: the original Meldrum's acid and DCM, the Meldrum's acid of heptanoyl chloride with half of the equivalence of the acyl halide added, the final 1-to-1 equivalence of the Meldrum's acid and acyl halide at 0 degrees C, and then I let the solution return to room temperature and stir for 30 minutes, and it looks a little more reddish than it does purplish, but we'll see what effect that has. Running them on silica plates with DCM as the mobile phase. Alright, so the reaction is done. I've poured it into a SEP funnel. There's some solid crystals floating around in there. Diluted it in a little bit of DCM. And I have 20 mils of 2 molar hydrochloric acid and water. Which I'm going to be putting in. I'll actually probably go make a little more of that. Alright, so the plan now is to remove the organic layer and extract the aqueous layer with DCM a few more times, and then combine the organic layer and DCM extracts, dry those or wash them with saturated sodium chloride solution, and then writeup, and we should get our recovered product. Alright, so the organic layer was extracted with 2 molar hydrochloric acid and then some saturated sodium carbonate. Adding some sodium sulfate here to try and clear this up. Looks a lot clearer, less cloudy. Also, we'll put this in a flask and see if we can get a mass on it and writeup it down. Alright, so the sample's been dried. It's a nice clear orange color, pretty much. Probably going to take a sample and spot it quickly on a TLC plate. Yeah, that's pretty much done. And then we're going to writeup it and hopefully get our recovered product. So we have a shitty pump, as you can hear, and we have to manually control the vacuum by turning the seal. So it's very prone to bumping sometimes, and it's also loud and horrible. So here the comparison of the two spectras. The one on the top is the Meldrum's acid, and then the one on the bottom is our final product after the couple hours of acylation and extraction. You can see it's pretty large in our final product and almost non-existent in the Meldrum's acid. And if you look over here at the chart, addition of an aliphatic alkyl chain is usually below 3,000. So I wish I had a mass spec to run things on, but as a first go, the reaction may have been successful.